When you work out an absolute value problem, remember that these are actually two different equations in one. So the first one we have, this right here, if I have 3 minus x minus 3, we know that from the definition of absolute values, we have one that's going to be exactly the same. So I have 3 minus x minus 3. That's going to give us one of the equations. But then I have 3 minus a negative x minus 3, because remember that absolute values can be positive and what comes out of this, you could have a positive and negative number inside that will still give you the same absolute value. So in a sense, we actually have two different types of equations here. This one is going to give us 3 minus x plus 3, and then this other one over here will give us, this will turn into a plus right here, so then we'll get 3 plus x minus 3. So that means that for this one, I get 6 minus x, and the other one here, I just get x. So I actually have two different equations. Now why is that? Let's take a look at the graph of this one. So this one here can be thought of as absolute value x minus 3 and then plus 3. When I draw the graph for it over here, you're starting from 0, 0, you're moving it 3 places to the right, and then up 3 units, and so you get this, and then you have these two lines that come down for each one. So this one's going to go through the origin, because it goes through 3, 3, 2, 2, 1, 1, and 0, 0. The other one over here, you go down 1 over 1, down 1 over 1, and so forth. That's going to take you down to here. And if you were to take that line and extend it back up to here, then you would get a 6. So these are our two different lines that I have. So when you do the integration, we actually have to split this up. We can't just do it all at once. We have to actually combine two different functions together. So here's the first one. The first one is going to be the line y equals x, and that's going to go between, since we're starting at 1, okay, so basically from 1 to 4 is the whole entire thing all the way across, but I'm going to break it up. I'm going to go from 1 to 3 with this line, and then from 3 to 4 with this line, and that's going to give me the whole entire area underneath that one. So whenever you have an absolute value problem, you do want to do it this way. Break it up and do a quick sketch to find out how you're going to have to break it up, because we can't just do it all in one step, because we're working technically with two different lines here, two different functions. Okay, so let's do the setup. The setup's going to look like this. We're going to first go from 1 to 3 of x dx, because that's this line right here that goes through 0, 0. Then we're going to add that to the integral from 1 to 3 of 6 minus x. Actually not 1 to 3, we're going to go from 3 to 4 there. That's the right one. So we're going to go 1 to 3 and then 3 to 4. And that will allow us to get the entire area underneath the curve. So we had to use 3 to 4 because you're working with this line in between 3 to 4 there, and that will get you this little wedge of area in here. Now we're ready to integrate this. So we'll take the antiderivative for this one, x squared over 2 from 1 to 3. And then we're going to do this one. That's 6x minus x squared over 2 from 3 to 4. And now it's just a matter of plugging in the numbers for each one. So I'll do that down here. 3 squared over 2 minus 1 squared over 2. And then next I have 6, I'll put 4 in. 6 times 4 minus 4 squared over 2. And I have minus. And then I'm going to do 6 times 3 minus 3 squared over 2. Okay. When I work that out, I'm going to get 9 halves minus 1 half, and then I'll do the part inside the parentheses. 24 minus, this is 16 over 2, so 24 minus the, that'll be 8 from that one. So 24 minus 8 will give you 16, and then minus inside here, you're going to get 18 minus 9 halves. So let me just go ahead and distribute that. Minus 18, and then plus 9 halves I'll get when I distribute the minus sign inside there. Alright, so now it's a matter of just simplifying it. 9 halves minus 1 half is 8 halves, which is 4. and then 4 plus 16 is 20 minus 18 is 2, so I get 2 plus 9 halves. And so that's 4 halves plus 9 halves. That means I get 13 halves as my answer. So 13 halves would be the total area underneath this curve. So again, the way to do this is you got to split it up. We have one line we did from 1 to 3, and then we did from 3 to 4. That combined, adding all that together, gave us 13 halves.